recorded the session. Okay. So the lesson is being recorded. So in case you want to see anything, the recording and be recorded. So today we are in week 6. We are going to learn Python libraries. So what are Python libraries? And what are basically Python libraries? That's what we are going to be looking at today. We're just going to see what are libraries in Python. So before we start learning what are libraries, we can just check at our today's objectives. So in our today's objectives, we want to understand what are libraries. Then we want to know how to install and import libraries. And also we have to know how to use popular libraries like random, like the math library, the date time, and other simple examples. So that's what we want to achieve for today. Not much, very simple stuff. Then after that, of course, we are going to learn the practical. Of course, we are going to learn with some practical. So what are libraries, or what is a Python library? A library is a collection of pre-written code. It's a collection of a pre-written code. In this pre-written code that we can use to perform common tasks without having to write anything from scratch. For example, we have a code that has already been pre-written by someone else or by still ourselves. We can use that code that has already been pre-written to achieve our tasks. So that means we are using a library. Also, we can create our own libraries. I'm going to show you how you can create your own Python libraries. So what is the main purpose again for learning these Python libraries? This is preparing us for next week, in which next week we are going to be learning things like we are going to be learning data analysis with Python, or maybe in that case it can be data science with Python. So basically that's what we are going to be learning next week. But this one for today is just an introduction to data analysis and Python. So we have said libraries is just a collection of pre-written code. So if we have a pre-written code, then that means so if we have a pre-written code, that means we are working with Python libraries. So we have two types of libraries. We have the built-in libraries, then we have libraries that we have to create by ourselves. Are you guys seeing the notes? Do you all have these notes that we are using? These I'm using here. Do you have the notes? If you guys don't have the notes, those who have already downloaded and also have saved these links, you can just kindly just copy the links and share with your peers. Just reshare on the chat. And if you see the notes, kindly click to download and save them. And also the links, you can click the link. You can click the link for this repo so that you can have the repo by yourself. Don't wait for it to disappear. Thank you. The PDF, kindly share. If someone has downloaded the PDF, kindly share with your friends. Kindly share. Okay, so let's continue. So we have built-in libraries. Then we have libraries that are external. That means we have to install the libraries. Okay, so an example of built-in library is the math library. So how do we use the math library? I'm going to show you how we use the math library with different examples on how to use the math library. So I just want to show you an example of how to use the math library. Let me share the notes. This is the last time I'm sharing the notes. Let me see. Where are they? They are too far. Just a moment. Python libraries, there we have. I've shared the notes. Check the PDF. Check the PDF right here. The PDF that I just shared. You can check it out. You can see it. It's not really a PDF, but Python libraries.pptx. Has anyone successfully downloaded this document I've shared? Yes, you can see so many people have successfully downloaded. I don't know why some are not. Almost everyone who has tried to download, they have. Yeah, it's the PowerPoint. It's the PowerPoint. It's not a PDF, sorry. It's a PowerPoint. Oh, people are saying if you're on mobile, you can't see it. You need to be on your laptop or desktop. Okay, let's continue. So I want to show you some code on how to use the math library. So for example, we import the math, or we import math. So we just use import math. Then if we import the math library, that means the math library can come with several functions inside it. When I mean by the library and functions inside it, this is what I mean. For example, it's just an example. This example for functions. I just want to show you this example for functions. No, I just want to see. Okay. When I mean, for example, is the math library? Yeah, this one. You see, when I mean math library can come with several functions inside it, this is what I mean. We assume this is the math library. A math library is basically like this file. So we have the first function and we have the second function. So we can write as many functions as we can. Then we can treat the whole file as one library. So this is what we mean by the math library. So the math library comes with operations like square root, operations like calculating the sine, the cosine, the theta, the radius, all those kind of operations, because it's the math library. So for the math library, we just write the math dot square root, then we pass the square root, or we pass the value that we want to calculate the square root of. Then we pass the number that we want to calculate the square root of. Of course, we know if it's calculating the square root, we calculate the square root of a number. So, okay. So that is the math library. Maybe another example that we can use is the power of, or maybe we treat like 3 raised into power of 2 or 3 raised into power of 10. So that's another example that we can use here. So we can just use the math dot power, or this means the like 3 raised into power of 5, just like the normal way that we did in mathematics. What is 3 raised into power of 7, 5, 6? What is 2 raised into power of 3? So it's basically the same. So we use the math dot power. Power means power. It's just like writing the power raised into power of. So instead of writing raised into power of, you basically write power. So is as simple as calculating that. So with that, then if you print out this one and also you print out this one, that means you are going to get the correct answer. For example, let's run this code and you can see the square root of 12 is 3.46, blah, blah, blah. Then 3 raised into power of 5 is 243.0. So basically that's how that's just an example of the math library. We have so many operations that you can perform with the math library. Someone is saying the elements is not working. I think it should be working. Let me see. It's working. It's working. I can see. I can see Python libraries right here. I can click and see the content. Yeah, you can see the content here. You can still see the content right here. So the LMS is working perfectly. The LMS is working perfectly. For students, maybe. Okay. Someone is asking for students, it never works. It's working. It's working. Someone, you can see guys are saying it's working. What is the difference between square root and is I square root? Let's see. Let's see. I've never seen something like this. Square root then is IQRT. Let's see. Basically, this is something like rounded off. The square root of I square root is something that off. Square root, that is 3.4. But the ISR is something that has been rounded off. It's just round off to the nearest whole number. Maybe what if we found the square root of 3.12.3, 12.3, 12.4, let's see. It's 53.5. So what if we use IS square root? Damn, it can't calculate a number with the decimal place. This one is not a whole number. It has to calculate whole numbers alone. But this you can see, you can calculate both whole numbers and decimal places. So another example is using the random choosing the random library. By using the random library is very simple. Maybe you wanted to print out a number in between 0 and 10 or 13. A number between 1 and 13. Any random number. So we import the random math. That means the random math is built in. It's a built-in library in Python. So it comes together with Python. The moment that you install Python, it installed all these operations, all these libraries, the basic ones. So we just use the random dot rand int. This is rand means the random integer. It's just like the random integer. Rand int or random integer of the range between 1 and 13. Of the range between 1 and 13. So if we run this code, first we import the random, then we pass the random dot integer dot random integer, then we specify the, what do we call it? We specify the range between 1 and 13. So it should print out any number between 1 and 13. So when you see random number is 1, if we run the code, random number is 12. If we run the code, random number is 2, random number is 8, random number is 10. So that means that one is working correctly. So in case you want this code to run this code is already here in that repo. This code is here in that repo that we just shared. It's working. Just check. We have that repo, the link, click the GitHub link. I mean this GitHub link here. It has the code, the pre-written code for this session. You can check it out. You can check that repo. That repo contains the code that we just worked on, this code here. This one here. You can check it out. You can fork the repo if you want. You can do whatever you want with the repo. It's all yours. Okay, so let's continue. Let's continue with our session. So we are done with the math, the inbuilt, the inbuilt, and also we are done with this slide because we have done the square root. We have done the square root, we have done the all this raised into power, and then you have also done the random integer. Let's continue on another example. Okay, so we have worked we have worked on what do we call it? We have worked on building libraries. So let's try to work with external or yes, external. Let's work with external libraries that we need to install them. So to install these external libraries, we need pip. We need to have pip. Where do you get pip? Pip is already installed in your machine. Why? You remember the moment that you were installing Python? It installed pip by default. So we are going to install it with pip. Pip is just like a package manager. So pip is a package manager for Python. So what is a package manager? This one will help you manage your packages, install your packages, or install any requirements that you need on top of your language. So let's say we have Python and we want to install something on top of Python that we already have. We have to use package manager that now will help me install that external package and also to be compatible with our normal Python. The same way for JavaScript, we have npm, we have so many package managers. Yarn, we have so many package managers. Now they will help me connect these package managers. They will basically help me connect between they will help me connect the normal Python and also now the external packages or external libraries. So I want us to test the first package or the first library, that is the requests. So we are going to explore this code and see the output. So just want to show you the code so that we explain what the code is doing. Yeah, this one here. Now, how do we install these packages? You just go to your terminal and do pip install the package. It's not a single request. Requests, plural. It is requests, plural, so it's requests. So if you install these requests, so I just click after press enter, then I wait for it to install. Remember, it will install depending with how fast your machine is. You can see mine just installed right away. My machine is faster, so of course it's going to install too fast. Okay, so after we installed the requests, now the request is already in our machine. So what do? So we import requests. The same way that we import math, it's the same way that we're going to import requests. So requests is a package that will help me make a request to a service. How? Maybe I want to make a request to fetch data from a certain API. Okay? So I will have to use the requests package or the request library to help me make the request. Now, let's say that I don't want to use the requests. Okay? I don't want to use the requests. So what can I do? I have to write my own code. I'll have to spend so much time trying to write my own code that will fetch data from this API. But I can write even 30 lines of code to fetch this data from this API. But by using request package, I just have to requests dot get. So the get is it's a CRUD operation. What is CRUD? CRUD is create, read, update, and delete. Basically means when you are operating anything, you are doing all those kind of things. You are creating a document, either creating a document, reading a document, updating a document, or deleting a document. Or that is just like the CRUD. So the get is basically the read. Go to the request, then get all the data inside this API. Then after you get the data inside this endpoint API, format that data into JSON dot JSON. Then you print the data, then you just print out the response right here. So for those who are going to specialize in ManStack, I think you guys will be seeing most of this almost every day. Almost every day, you're going to be interacting with JSON files. So this one will not have to scare you. You are going to be mostly interacting with these kind of things. Okay. So after you use the request, you just use the request.get any data inside here, format it in form of a JSON or return it into a JSON. Then from that, you can print out, you can print out all the responses or the data inside that API. So the moment I run my code, I can see it's waiting because the data is too much. There we go. Now you see they have printed out this data from this API. Actually, these are valid repos. These are valid GitHub repos you see here. Let's see one repo. I just want to get a straightforward. Let me see. I'm trying to identify a valid repo. Okay, let me run the code again and see if it's going to return valid repos. Oh, this is events. This is events. This is events. Maybe I can change this to I think users. I'm not sure. Trying the endpoint. Just trying it out. Not sure. I'm not sure. There we go. There we go. They has returned some few users. Let's see if we get valid users. API. Then it's not returning valid users here. Working with valid users. Let me just go person. Yeah, exactly. Actually, it's returning actual users. It's an attack, but actually this one returns actual users. So let's see. This user Mojombo actual users. Let's see who is Mojombo. Okay, sorry guys, my network just decided to drop me. Okay, my network just decided to drop me. Worry not, worry not, worry not. Actually, you can see GitHub is returning actual users. It's returning actual right here. You can see these are actual users. This is the picture of this guy is here. Actual users. This guy has been programming since was I 2006. Someone was programming in 2009. We are too serious in this world. Am I still breaking? Am I still breaking, guys? My audio is not clear. I'm having an unstable network today. I don't know. It's only today. It's only today my audio is not clear. But anyway, so we have learned on how to use requests. So we can go further and learn what is NumPy and pandas. What is NumPy or NumPy? This one here, the NumPy. What is NumPy? We are going to see what is NumPy and pandas. So the two libraries, that is NumPy and pandas, they are used in data analysis, scientific computing, and also in machine learning. So basically, those two libraries are used for that case. That is data analysis, scientific computing, or machine to use both in two. Data analysis and also machine. Be using for the pandas and NumPy. Okay, I think now I should be okay. Man. We lost you completely. Yeah, I also lost you completely. We lost each other completely. You can hear me? Can you hear me, guys? Clearly now? Good one? You can hear me? I can also hear you. I can also see your text. Oh, that means we are good. We are good. We are good now. Yes. Thank you. We are good. We are good. I hope you can still see my screen. I hope you can see my screen. You can see me moving around with my cursor in my windows here. Okay, cool. Thank you, everyone. Yeah. So, what is NumPy? NumPy, we said it's numerical Python. And what is numerical Python? Is just numerical Python. It works with numbers, basically working with numbers for NumPy. So in NumPy, we are going to work with large arrays and matrices. And also we are going to use this to perform mathematical operations on these particular arrays. Okay, so let's continue and try some few examples right here. It's only the simplest example that we can get. So we are going to see our code and see some of the examples and explain these examples right here. So in this code right here, remember okay, sorry. I was just grabbing a glass of water. Someone just hacked me and said that JS Mommy calling. No, she can't be calling at this time. She can't be calling me at this time. I'm busy. Anyway, she knows her time to call. But anyway, I'm single. I'm still single. Last week, JS Mommy didn't come through. Anyway. Okay, let's continue. Where are we? So, we are going to use this NumPy. We are going to use this NumPy or this NumPy example right here. So, how do you install NumPy? How do you install NumPy? We just use pip install NumPy. We do pip install NumPy. Okay, so in this pip install NumPy, you just install the NumPy like that. So it depends again how fast your internet is and how fast your machine is. then you'll have NumPy installed in your machine as it should. Okay, so now after we install this NumPy, it's a library, so we have to use this library right here. So how do you use this library here, this NumPy library? So we import NumPy as NP, as NumPy. NP stands for NumPy. Let's assume that we have an array that you want to use NumPy to perform some few operations. Like for example, I have my array that is variable. Then I use this NumPy dot the mathematical operation or the operation that is I want to perform this or I want to format this in an array. So in this array is just a list or an array of numbers. And what are these numbers? 1, 2, 3, 4, 5, 9. Okay. Now, what I've done here is formatted this in a form of an array. This is a number, but is in a form of an array. So, I can do some few simple things, like how can you multiply an array times 2? How do you multiply an array multiplied by 2? Basically right here. So I do my array, this is my array, multiplied by 2. So what is the expected output? We expect in this array, whenever we are printing out this array back, we print out 1 multiplied by 2 is 2. 2 multiplied by 2 is 4. 3 multiplied by 2, 4 multiplied by 2, 5 multiplied by 2, 9 multiplied by 2. So that's what we expect when we print out this particular array. Also in this array, we can calculate the mean. How do we calculate the mean? We use the numpy.themean method or the mean function. So how do you compute that mean? We just write np or the numpy.mean. The numpy.mean. So dot mean, then we pass the array. So we are going to calculate or we are going to find the mean of this particular array. Also, we can find the square root of this particular array. So we use the numpy dot square root, then you pass my array here. So again, just like how it did the multiplication, it will do the same for the array, for the square root. It will go to 1, find the square root of 1, find the square root of 2, square root of 3, square root of 4, square root of 5, square root of 9. Then print out the square root of each. Let's see the example right here. So if an array is multiplied by 2, 1 multiplied by 2 was 2, 2 multiplied by 2 was 4, all the way to 18. So that means it has done the multiplication of this particular array multiplied by 2. So what is the mean of this array? The mean is 4. So what is the square root of this particular array right here? So it will go to 1. What is the square root of 1? Is 1. Square root of 2 is 1.4. Square root of 3 is 1.7. This number. Square root of 4 is 2. Square root of 5, 2.3. 2.23. Square root of 9 is 3. So it will go to this array, find the square root of each, then print out the square root of each. Again, it will check the array, take um, each part of this array multiplied by 2, multiplied by 2, and print out the output after it's done with the multiplication. So that's an example of how we are going to use this NumPy. Someone is asking, in real life, how can we use this NumPy? Next week, don't miss the session. It will be, I think, almost the last session for Python sessions. So next week we are fully going into data analysis. So this week or today we are just doing the introduction and setting up some of these things, because next week we won't be setting up these things. We'll just go into go pip install NumPy, pip install pandas, and we won't be explaining much what they are, because already this week we'll have done the introduction. This week is just the introduction of these libraries. We are going to use them and we are going to give better examples on how to use these libraries next week when we are doing the data analysis. The last one, the last part that is going to have example as well, it is the pandas. What is pandas? Pandas is used for data manipulation and data analysis. What is data manipulation? We can manipulate data, how it looks like, to have a different format. If it was in rows, if it was in rows, you can change this data from being in rows, being planned or being stored in rows, to be stored in columns. So that is an example of data manipulation. So pandas is basically used for that, data manipulation. So we can manipulate how data it look like for the purpose of better analysis. So you can perform that in Excel and also in Google Sheets. So data manipulation also in pandas helps us filter data easily. And pandas, the library itself, can read CSV, Excel, and JSON, among others. So how do we install pandas? To install pandas, it's very simple. You just do pip install pandas. The same way that we have done for NumPy, the same way that we are going to install for pandas. So let's install pandas. It's very straightforward. We just run pip install pandas. Pip install pandas. Pip install pandas. Then we just run. Then there we go. Pandas has already been installed. You have already installed pandas in our machine. It's very simple to install pandas. Okay, so let's check that example, that final example, that final. For those who joined late, we had some few notes that we shared. We shared the repo, and also we shared some few notes that we are using Python libraries. You can check out the notes on the chat. You can check out the notes on the chat. The notes are there on the chat, guys. So for those who joined late, kindly you can check so that you won't flood so much. You don't get confused where we get in all these examples. The repo here contains the code in week 6 for whatever we are doing. You already have these codes right here. So you can fork the repo, you can download, you can do whatever you want. That's the repo. Okay, so okay, I was just testing. Okay, let's do the last example. We have around 10 minutes max. So I'm just buying time so that we use our time well. Okay, the last example is right here. So this is the last example that we are going to check with pandas. So because we already installed pandas, I'm going to import pandas as PD. So I'm going to import pandas as PD. So this is the last example. I know you guys, you are going to like it. I know you are going to like it. We are not going to use the example that we have seen right there. So remember last week what we did? What did we create? Someone can tell me who was there last week. What did we create? Um, it was a very exciting example. You guys liked it. I can see Lidiwe, I can see you. We created JS Daddy's girlfriends. We had so many girlfriends, right? I created several. Now, I want to use pandas. I want to use pandas and create a sheet because I have too many girlfriends and put them in a format. Okay. Okay, let's do this. Let's do this. No. Don't get worried. Don't get worried. Don't get worried. I can see someone who is worried here. Why is it only ladies who are remembering what I created? Specifically this Annie. Annie, I see you. I see you. Okay. Let's say I have several JS mummies because they call me JS daddy. How do you write JS mummies? Mummies. We have JS mummies and we have their names. For example, we have their name. You can see even my figures here. We have my name. We have their names. Okay. And the first girlfriend is, let me select one from this class. No. Hey, you see, Evelyn is telling, I use me what? Annie, Evelyn. Hey, I can see you, Evelyn. I'm not going to do that. Maybe we can use Annie. Oops. It was Annie. It's just an example, guys. Don't take it serious. I can use Evelyn. Is it Evelyn? How do you write Evelyn? Then maybe I can go. I want a Nigerian girlfriend. Can give me a name and don't lie to me because I don't know Nigerian names. Someone is saying Ikechuku. Is Ikechuku? You guys don't lie to me. Let me use someone like Grace. Hey, you can lie with me with those names because I don't know their names. Okay, now I have their names, and for example, I have an example like age. I have their age, so I need comma here. I have their age. The age is still like this, should look like this. Yeah, I have their age. Okay, and maybe something I have like height. Okay, I have their height. As you can see, it's average height because I'm 5.8, so they should be somehow shorter than me. I'm 5.8, so they should less be shorter than me. So I have this list of these girlfriends here, right here. So what I can do here, is, for example, let me show you something. If I print, no. So you can see this data when a normal person checks this data makes no sense. Okay, all this data makes zero sense. I can create a data frame. I will explain what is a data frame after we see the results. PD basically means these pandas that we just created here. So PD dot data frame, then I put all this list of these people right here. Okay, so this example here, then I'm going to print the data frame. Basically this one, you can say, instead of just writing the data frame, instead you are wondering what is a data frame, you can use a normal variable that you can use here, any normal variable. So any normal variable can be like girlfriends table. Maybe I'm creating a system that I just want to see the list of girlfriends that a certain person I know has. So I can just print out that table right here. So once I run this code, you can see this data. Let me show you the difference. You can see this data here makes no sense for us. Only machine can understand this code. We are developers, we can understand, but totally we can't understand this code. We can't understand anything right here. So once we run this code with pandas can format that data in this kind of a way. A data frame is basically something, we can call it a table. A data frame is like a table. In this table, it's going to store the list of things. So this data is unformatted, just like this. Now, once we run our code, you can see, the name is Annie, age of 25, and height of 5'4". Evelyn, age of 30, height of 5'6". Name is Grace, age 28, then height of 5'5". So you see with pandas, if we have unformatted data, we can format it into a data frame. So using data frame, we can format data and make it more presentable. Now assume that we are analyzing this data. You want to analyze this data. That's when we use these pandas, analyze this data and make it presentable. Now, once we make the data presentable, it will be easy for us to create graphs and show trends. And imagine, as that simple example as it looks, that marks the end of our session. So, yeah, that marks the end of our session with that small example. But before we leave, someone is saying Evelyn is very old. Evelyn is very old. Do you remember last week? Last week I had a girlfriend who was 46 years old, a very young girlfriend here. 46 years old, very young, very young. You guys are monitoring me. Someone is saying it was not 46, it was 45. And it's Brenda. Is it Brenda? Someone said it was 45. Why are you guys tracking me, man? I don't like this. I don't like this at all. I'm just saying 46. Or maybe I have too many. I can't remember their age. Let's just go with the 45 that you guys know. Let me not hide. Let me not show the rest. So I had a girlfriend who was 45 years old. Can see, yeah, it's 45 and short, 5'6". Yeah, yeah. Very cool. Anyway, guys, don't take this serious. All these are examples to make the class fun. Don't take it serious, man. Don't ever take it serious. I can see Annie was in the list, but she's smiling. I know that smile. It's not a smile of it's not a smile of a normal smile. It's a smile of anger. No, Annie, don't smile. Don't be hungry. I can see Evelyn is complaining. Evelyn, you are not that old, I know. Just making fun. Anyway, guys, next week we are going to do data analysis with Python. So get ready. We are going to have some crazy examples that you guys should be ready to enjoy the session. So make sure that you do your weekly assignment to make sure. Hey, Annie is complaining. You can see, everyone see, I'm sharing my screen. And he's saying, please don't replace me. With who? Anyway, next week, get ready, you guys. We are going to do data analysis with Python. So immediately after the session is over, I'm going to upload all the recordings. I'm going to update the recordings for this week. So in the meantime, you guys, we have some this code. I'm going to share the code again. You can check out the code. You guys, you can support me. You can support your daddy by subscribing to his YouTube channel right here, right here, right here. This chart, on this chart. What do I say? What do I say? What do I say? I just want to say thank you guys for joining. Thank you for taking your time to join this session. I know you are learning. So in 2 weeks time, we are going to specialize. We are going to learn machine learning. We are going to learn AI. We are going to learn full stack. We are going to learn mobile development just 2 weeks away from now. You guys get ready. You guys just get ready. You are not ready for this. You guys are not ready for what we have prepared for you. Thank you guys. Thank you. Thank you. Have a lovely night. Have a good night. I hope you enjoyed. See you in the next one. You guys, we love you so much. Enjoy your evening.